We're now going to be in chapter 4, talking about a prime number. A prime number is a whole number that has exactly two factors, 1 and the number itself. You've got something in front of you that is a prime factorization of 2. 2 is at the top of that tree. And we have listed the factors of 2. The factors of 2 are 1 and 2. That makes it a prime number. Why is 12 not a prime number? It says it on there. The number 12 is not a prime number because it has more factors than 1 in itself. I've given examples of prime numbers, which are 2, 7, and 23. Those are prime numbers because the only factors that it has are 1 and itself. A composite number is a number that can be broken down into 2 or more factors. So the factors of 16 are 1, 2, 4, 8, 16. So 16 is a composite number. Now we're going to list the composite numbers between 1 and 30. I'm going to call the number out. You're going to tell me yes or no, and you're going to write them in your notes. 2. 4, 3. 3. We are listing the composite numbers between 1 and 30. 3 is a prime number because its factors are 1 and 3. 2 is a prime number because its factors are 1 and 2. Is 4 a composite number? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Because 2 times 11 is 22, 23, 24, 25, 26. It's an even number, so 2 will go into it, so 26 is composite. 27. 3 times 7 is 3 times 9 is 27. 28. 29. 30. Now we have the composite numbers between 1 and 30. On our next screen, we're going to write all the factors in order of each of these numbers. So I'm going to start with 1, and then since they have to be in order, I'm going to list them like such. 3 times 5. Any other factors for 15? No. Got 15 right here. So our factors for 15 are 1, 3, 5, and 15. So the factors on B are going to be 1 and 26, 2 and
3. No.
So your factors for 26 are 1, 2, 13, and 26. How do you know if that's all the factors? You go through your divisibility rules for 2, 3, 4, you don't 5. You have to know 6 if 2 or 3 goes into it. 7, you'll just have to know off the top of your head or divide. 8, same with that. You'll have to know off the top of your head or divide. 9, we discussed the rules for 9. So you need to go through at least 1 through 10 to see if that number is divisible by that. And then find its mate. Find what other factor goes with it. So in 75, we have 1 and 75. So that I don't forget them, I'm going to do their little mates, what factor goes with it. 3 and 25. If you have 3/4, you have 75 cents. 5 and 15. So your factors of 75 are 1, 3, 5, 15, 25, and 75. Now, let's list D. 64. 1, 64. So you'll notice now we've listed the factors for 64. 1, 2, 4, 8, 16, 32, and 64. Now, these two phrases are extremely important for you. The number 1 is neither prime nor composite. The number 2 is the only even prime number. Those two phrases are extremely important because you will see them again this year and as you continue on in your education. Now, in our next slide, we're to tell whether the number is prime or composite. Explain your reasoning. Now, I'm going to pause the video. We're going to discuss it, and then I'll put the answers on the board. Now, in your notes, you should have written down what each one was. 88 is a composite because it has a factor of 2 and 44, but you only need to discredit it by just saying it's not 1 in itself for it not being a prime. B, 23 is a prime because it's only two factors of 1 and 23. 61 is a prime because it's only two factors of 1 and 61. D, 201 is composite because when you add 2 plus 1, they equal 3, so it has a factor of 3. 39 is composite because it has a factor of 3, and 19 is prime. Now, in our next slide, we're going to talk about a prime factorization and how to use prime factorization. Prime factorization breaks down a number's factors into prime numbers. This can be done using factor trees. So in your example, the number 24 is being broken down into what's called a factor tree. You take the number, and when I do a factor tree, I usually start with the smallest number that will go into it other than 1. So if you'll notice in 24, 2 times 12 is 24. I circled the 2 because it's a prime number. 12 is not a prime number, so I need to factor it out with prime numbers. 2 times 6. I circled the 2 because it's a prime number, but then I need to factor out the 6 again. 6 factors are 2 and 3. So with the prime factorization of 24, I circled all the numbers that are prime. So the prime factors of 24 are 2, 2, 2, 3. Once you have a prime number, you stop factoring. So once there's a bubble or a circle, you stop factoring it. So where it says in orange, no matter how you break up the prime factors will always end at the same. For example, this is my tree right here. That's Layton's tree. 56, I did the two factors for 56 is 7 and 8. I circled the 7 because it is a what number? Prime. Is 8 prime? No, so I need to factor it out with 2 and 4. The 2 is circled because it is prime, but the 4 I needed to also factor it out. So now the prime factors of 56 are 2, 2, 2, and 7. Well, Layton started his and he used 2 as his factor. 2 times 28, and he circled 2 because it was a prime. But then you factor the 28, 4, and 7. Then we need to factor out the 4. So you'll notice that in 56, its prime factors are 2, 2, 2, and 7. Notice our trees are different, but they have the exact same prime factors. So you're going to use an exponent when the prime factor appears more than once in the prime factorization. You need to write these in order from least to greatest. So in 24, in your previous notes, 24 was 2 times 2 times 2 times 3. How your final answer will be 2 to the third times 3. We have 3 2s, so that would be 2 to the third times 3. In 56, we had 2 times 2 times 2. We had 3 2s times 7, so that would be 2 to the third power times 7. So when you are writing your prime factorization from your trees, you go from least to greatest. A factor tree is one way of doing prime factorization. Another method that you might see is called the L method. It's also called the upside down division, where you take 24 and you're going to find the prime factorization of it by dividing. 2 into 24 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. So our prime factorization, our factors are on the outside of the problem, so that would be 2 to the third power times 3. We stop when our last number is prime, and we cannot divide into it anymore. So on 56, we do the upside down L method. Upside down L method for the factorization. So we would do 2 goes into 56 28 times. 2 goes into 28 14 times. 2 goes into 14 7 times. So again, you'll see that your prime factorization is 2 to the third power times 7. Be very careful to make sure that your exponent looks like an exponent and not another digit. Now we're going to do our own factor trees. We are going to show the prime factorization of 48. So the number that I would start with would be the smallest number, which would be a 2. I'm going to circle that because it's a prime number. 2 times 24 equals 48. So I'm going to have 24 here. 24 is not a prime number, so I need to factor it out. And as I'm making my trees, I'm circling the numbers that are prime. So the prime factorization of 48 is going to be 2 to the fourth power times 3, because I have 1, 2, 3, 4 2s and 1 3. Now, do 26 on your own and come back and check it. So you'll notice when we do the prime factorization of 246, we factored it out. We have our prime numbers listed. 2 times 3 times 41. When you multiply, 2 times 3 is 6. 6 times 41 is 246. Now, do the factors trees for 198 and 726. Pause the video and come back and check your answer. So as you check your trees, notice the circled numbers are the prime numbers, and we told them at the bottom. 2 times 3 squared times 11. And on 726, the prime factorization is 2 times 3 times 11 squared. Now, you will notice this type of word problem using prime factorization. You will notice it in tests, you will notice it in graded worksheet, and most of all, you'll notice it in your exam. A photographer wants to arrange 40 students in rows of the same length. Find the possible row lengths by writing all the factors of 40. So write the factors of 40 going from least to greatest, and then we'll set them up for the rows for the photographer. So you'll notice that we listed the factors 1, 2, 4, 5, 8, 10, 20, 40. The question was asking the possible row lengths writing the factors of 40. So you could have 1 row of 40, 2 rows of 20, 4 of 10, and 5 rows of 8. Or you can have 40 rows of 1, 20 rows of 2, 10 rows of 4, or 8 rows of 5. So do you remember what is the only even number that is prime? 2. It only has two factors, 1 itself. Why is 1 a special number? Goes into every number?
It is neither composite or...
Correct. It's neither composite or prime. Very important to remember that. How many factors does each prime number have, class? How many? 2. And our last question is, can a composite number have exactly 2 factors? No, because then it would be a prime number. Let's review some of our terms. The only one I want you to write in your notes is the very last one, because that's what our lesson is going to be about tomorrow. So when I get down to number 5 is when I want you to write that term down. Number 1, factor is a number that multiplies to make up another number. For example, 4 and 3 are factors of 12. A prime number is a number with exactly 2 factors, 1 and itself. Composite numbers, a number with more than 2 factors. Prime factorization is an expression expressed as a product of factors that are prime numbers. And your final term that we will be discussing tomorrow is the greatest common factor, which is capital G, capital C, capital F. And that definition that I need you to write down is the greatest number that is a factor of all the integers. The greatest number that is a factor of all the integers. So we have discussed a prime number, composite number, and prime factorization, and reviewed the factor term. So tomorrow we'll be discussing greatest common factors. Now on the next screen, you're going to circle the prime number in your 100 square, and you're going to mark out the composite numbers. Remember, if 2 is a prime number, all the multiple 2's are composite and can be marked out. So you'll notice that on each one of these, if it's a factor of 2, they will be marked out, and circle the ones that are going to be prime numbers.